Hello 8th graders and welcome back to my YouTube channel. On today's exercise assignment, you may have noticed that there's 63 through 73. This may look rather extensive, but actually, as you can see, some of these are pretty simple, but you've got to be careful with what you're putting in here, because if obviously you put in the wrong answer, it's going to ding you, and it could have a cascading effect. That's okay. Let's walk through these. For each real function f is an element, that is that fancy L of R, and that's the set of all real functions where the domain of f is real numbers and the graph is some straight line. Oh, that's why it has the L, so it's talking about the real number straight line functions. It says if and only if there is some b that's an element of set of reals such that f is defined by all x's that are elements of real numbers by, and I tap on this, and we should, as we look at this here, if we're saying, wait a second, when we talked about the preceding exercise, that was the one we were multiplying, right? So let's choose b times x, and we'll hit submit. And we'll say yes, and we should get our happy little check mark, sure. So as you then move on to exercise 64, it's saying, hey, is this going to be an operational system? In fact, I'm going to say that it is an operational system. Because, as we showed before, when I have these, when I have b times x plus c times x, I can just simply add the b plus c times x. Whoops, sorry here. Whoa, wrong. There we go. Try it again. There we go. B plus c, which of course is an example of distributivity. And we hit submit, and we get our gold star for that one. So let's move on here on down to 65. And as you go to complete 65, it says you've discovered that, yes, that addition of those linear functions in real numbers is an operational system. Do you suppose it'll be associative? Spoiler alert. It is. It is associative. Whoopsie. Sorry, hit the wrong thing there. There we go. And great, Scott, we got this long proof to fill up. But that's okay. This is relatively easy here because the choices are pretty logical, I think, as you can see. We can break this apart, say f plus g of x plus h of x, like so. And then I can, of course, split that into f of x plus g of x. That makes sense for the preceding one, of course, which f of x was b times x and g of x was c times x. So I'm going to choose the top one, like so. And now I will, I can just change where the parentheses are using associativity of real number addition. Oops, it did it again. There we go. Associativity. There it goes. All right. Sorry about that. Let's see. So the next one here for my choices, I can say f of x plus, and I'll say it, since it's still in those groups, g of x plus h of x. That's what we define c times x and d times x as. And now I can pull that apart again. Just pulling the x out there and say f of x plus g plus h of x, or simply f plus g plus h L of x. And I should get a gold star on this. And I did. Yay, gold star. So let's head on down here to exercise 66. So it opens up the next one. You've discovered that addition is an operational system. Do we think we have a neutral element here? Actually, we do, because on exercise on exercise 66 here, we can see that where b, interestingly enough, is 0, right? So when I say if b is 0, then f, given for all of the exits and elements of the set of reals, yeah, this is going to allow us to complete this exercise here, because when I write down here, when I go down here to b times x plus c times x, this is simply going to be c, because remember we just set up here where b is 0, and by, let's see, so g plus f of x equals g of x plus f of x, c times x plus b of x will still equal just plain old c of x. So c in both of those blanks, folks. And yeah, and so f plus g is going to be equal to g, or g plus f, because when it's 0, it's going to make make a nice neutral element there. So again, I got my gold star. Good for me. Let's move on to exercise 67. So it says you've discovered that it has a neutral element, namely the 0 element of, on those sets of reals, of course. So now we're asked, is this invertible? Say that it is invertible, okay? So we're going to let f be an element of that operational system, or straight line equations. There exists b as some element of the set of reals, such that x is an element of the reals, and f of x equals b times x. Let g be an element of that system, and be defined for all x's that are reals. So by g of x equals, and we're going to put in negative b here, because again, I'm looking for invertibility. So I just typed a negative b in there. Make sure it looks like that. I mean, the negative's kind of off my screen, but I need you to understand that. So again, g of x is representing the negative b of x, like so. And so that means here again, I'm putting b, plus negative b. And b plus negative b, of course, is 0. It takes me back to the neutral element. Rather important, of course. And you may have been able to just reverse engineer this, probably. So, so f plus g equals that 0 element. And a similar argument shows that g plus f equals 0. Thus, g is f's inverse. And it's invertible. I hit submit. It says confirm, and it's happy. And the last one on this page, there's a lot going on here, wasn't there? On exercise 68, you've discovered that we have a group, right? And so now you're asked, is it an abelian group? In fact, it is. It's doing it again. There we go. It is an abelian group. Here we go. Because remember what abelian means, right? It's commutativity. So pretty, so almost immediately you should just go straight to commutativity of addition. And what's going to complete this? Pretty obviously, c times x plus b of x. See how it's just perfectly flipped around from the preceding one? No problem at all. Hit submit, and your should be done with this page. A nice series of gold stars. So there you go. There's your walkthrough of page 52. Continue on for today's lesson for page 50. It starts on page 53. Thank you for watching. Be sure to subscribe to my YouTube